Alrighty, good morning everybody. Could I get a quick confirmation that you guys can hear me? This is a good practice for your Q&A, your questions. So just go ahead and type in the question bar and somebody let me know that they can hear me. Perfect. So throughout the presentation, if you have any questions, any topics you want me to try and cover, just go ahead and put a note in the Q&A bar. It's either going to be at the top or the bottom of your screen depending on the layout. My name is Matt Walker. I'm one of our trainers here at SimpliPhi Power, and today I'm going to be giving you a presentation on battery sizing, battery and system sizing. So we're going to talk about really how to size the storage system for several different applications. I want to start off today by letting you know a couple exciting things are happening. So I'm going to be giving away a shirt and a hat today during our presentation to the person who answers the most poll questions correctly. I'm also going to be giving out passes, free Expo Hall passes to SPI at the end of our presentation. I'm going to announce a photo submission contest for that. So please stick around. Again, a lot of exciting things happening today, and I hope we can all come away with something. Looks like my clicker's not working. That's all right. Just going to go ahead and get started. So I'm going to start today with a company overview, and then we'll kind of go through an overview of our products and then different sizing calculations and applications. So first off, we were actually founded in 2010 as OES Energy. So we were born kind of into the mobile market, making Hollywood filmmakers power packs for their film equipment. Really proved our roots in the mobile industry, which is really a pretty hardcore application for batteries. And we were founded to solve a problem in that industry. That problem was unsafe lithium chemistries that were causing hazards and lead acid batteries that were failing and not meeting the needs of those filmmakers. So in 2011, when the military, had a project that they asked for proposals on, they said, we don't want any lithium batteries. Don't even bother submitting your proposal. However, we were able to convince them to just put our batteries to the test. And when they did, they were able to validate our claims of just how safe our batteries were. So again, the military testing in 2011 at the Aberdeen Proving Grounds, which is not far from my hometown, actually. Many of my friends work there now. That was really the proving grounds for our battery as well. Proving just how safe it was, as the military did end up using it in that project. In 2013, we expanded our product line, really focusing on consumer and installer friendly solutions. In 2015, we relaunched as SimpliPhi Power, and now we're ramping up manufacturing at our facility in Ventura County, California. So almost all of our products are UL certified. 1642 is the cell level certification. 1973 is for each module or each battery. And 9540 is really for the system as a whole. So that's going to not only evaluate the safety of each component, but also how all the components in the system, such as the inverter, the battery, the charge controller, how they all integrate together and work together safely. So we have several configurations that are 9540 approved, and we've completed our 9540A testing if that's needed in your jurisdiction. Our batteries are used in a variety of applications, and we're going to be talking in depth about how to size for these applications today, as well as what they are. So I'm going to kind of jump through this slide and just know that we'll talk more about these applications later. So first, for an overview of our products, Understand that we make scalable and modular solutions. We use only lithium iron phosphate battery chemistry. So this is really what we feel is the superior battery chemistry because it's the safest. There is no danger of thermal runaway and fire like we see on the news all the time with cobalt-based batteries. It's not the case with lithium iron phosphate. Now, not all lithium are the same. This is really because of the lack of cobalt. Cobalt's a very energy dense material and it can release a lot of heat very quickly. So without that, there's really no danger of thermal runaway and fire propagation, no toxic elements in our battery, making it actually landfill safe. Although, of course, we'd like to see it recycled. If that's not possible where you are, know that it is landfill safe. There's no abusive mining practices involved in the creation of the battery in the supply chain. No ventilation, cooling equipment, or safety monitoring equipment required. And it's able to withstand even higher temperatures than most other chemistries, up to 140 degrees Fahrenheit for operation. Another key feature that we all need to understand before talking about sizing battery systems is the C rate. So the C rate is really just a measure of the rate at which the battery can charge or discharge relative to its total capacity. So for example, a lot of lead acid batteries are rated at C over 20, and their discharge rate is maximum something around C over 5. So this means they can discharge pretty slowly in about 5 hours. Now, with our batteries, they're rated at C over 2, which means they can charge in 2 hours and discharge fully in 2 hours. For example, a 3.8 kilowatt hour battery that can discharge at a rate of 1.9 kilowatts, and that scales up as you add more batteries to the bank as well. Now, this is our 3.8 kilowatt hour battery, which is kind of our bread and butter. This is definitely our most popular product at the moment. It is infinitely scalable, which means you can parallel as many of these batteries as you want. No series connections here. It's made only for 24 or 48 volt applications, and it's made to be wired in parallel to a common bus point. We'll talk a little bit more about wiring later. But know that this is, created as a lead acid replacement, but it really can be used for all sorts of things. It's not limited to just replacing lead acids. It's used for all sorts of projects nowadays. It's got an internal battery management system that's going to keep the cells balanced and provide protection, of course, and a circuit breaker on top. Now, I think the circuit breaker is one of our most underrated features. This is really helpful for installation, and I don't know why everybody isn't using one of these on their batteries. It's so nice to simply turn off the battery before installing it, get everything done, get everything wired up, no chance of shocking or short circuiting. And then once you're finished and ready to power up the system, then go ahead and flip on that breaker. I think that's a big advantage. Oh, excuse me, I slipped through one there. Our SimpliPhi is our newest product, so it's the same capacity and same exterior dimensions as our Phi battery. However, the SimpliPhi has closed loop communications with with communicating inverters, such as right now it's just the Solarc inverter, but we are quickly expanding that list. There's no external cards required for this communication, so it just hooks up with the standard, Ethernet cable from battery to battery, and then last battery to the inverter. When you connect these communications with the Solarc, it's going to not only auto-populate some of the charging set points and battery protection, but it's also going to allow the battery to communicate its own charge rate and other settings to the inverter. So if you've got only one SimpliPhi battery connected to a Solarc 12K, the SimpliPhi will actually tell the Solarc, hey, I can't handle your full charge rate. please limit your charge rate to 37.5 amps. That's all I can take, and the solar will listen and adjust. Now, this is not something I would do with the Phi battery. You cannot just connect one Phi battery to the solar. But because of the communications, you can actually connect a smaller bank to a larger inverter with the SimpliPhi battery. In addition, it's going to give you a really high level of accuracy for readings such as state of charge, voltage, and charge and discharge. And if you're using SolarX, PowerView software, you can not only see these in real time, you can see how many amps the battery's charging and discharging or its current state of charge, but you can also see the historic data, which is really helpful for any troubleshooting that might come up. Now, the SimpliPhi is actually limited to 40 battery modules. So when I said infinitely scalable for the Phi, know that that's not quite true for the SimpliPhi, but 40 is a lot of batteries. In a residential setting, I have yet to see somebody run out of room with 40. Our access unit is becoming more and more popular because of the pre-wired and crated delivery. This is making it really convenient for installers to have the inverter already mounted in the cabinet, already wired up and ready to go. Plus, we've seen a lot of California, code restrictions are pushing installers towards just putting the batteries outside. It's making, approvals a lot easier as the code evolves towards that. So this NEMA 3R enclosure is ready to sit outside. It's able to withstand rain and all sorts of weather. So this is becoming more and more popular. I really see it as the code evolves towards pushing installers outside. So we're going to talk about how to use those products we just talked about in terms of sizing for different applications, where one fits in better than the other. There are so many different ways to size equipment because there's so many different applications, right? So a grid connected home, you might have a whole home backup. A customer might not want to ever, reduce their load, and you may have a customer who just needs critical loads backed up during an outage. You may be sizing a system for an off-grid customer. That's actually my favorite. Or you might be replacing a lead acid or even a lithium battery system that's already there. So in terms of whole home backup, when you're sizing a storage system for a whole home, the layout is generally gonna look like the main loads panel on one side, the critical loads panel on one side, and the inverter is going to be in between them, being kind of the buffer between them. You're going to often move all of your loads to the critical loads panel so that they can stay on when the grid is disconnected. Now, often this requires a huge battery bank, right? If you've got an entire house that you're backing up, just the instantaneous demand that you could pull if you turned on several appliances at once is quite large. So what people are doing nowadays are installing smart load panels. So smart load panel is going to help you distribute loads accordingly, turn off any circuits that you need to turn off from the comfort of your cell phone, and really distribute that power more wisely. And it's also going to kind of have an SOC meter that's going to tell you just how much battery capacity you have left. So smart load panels are really helping customers who want to do a whole home backup do that with as small of a system as possible, keeping the initial expense low. Now, sometimes people size just simply off the main breaker size in their panel. However, I think more often installers are going to be pulling that utility bill, and they're going to be looking at not only the peak demand, but also the kilowatt hour energy consumption. And then they're going to ask you, how many days do you want to go off your battery bank before it needs to recharge? Most often, since you're not cycling these batteries daily, you're going to be sizing for 90% depth of discharge instead of 80, which is what we recommend for systems that are cycled daily. Having a bit of trouble here advancing the slide. There we go. So for an example, I found this great photo of a whole home backup in the left side of the screen right now with a lumen panel. It's a bit blurry, but hopefully you can see that lumen panel right there. And that's really controlling this critical loads panel. And we see our access unit is a great fit here as well. So that lumen panel is really going to help this customer make the most of their battery bank, even if it's not, able to keep them off grid for 10 days. It's enough to distribute their loads wisely so they don't run out of power quicker than they expected. Now, if your customer wants to later on expand their system, they're having more power outages than they were initially. What you can do is, luckily with 5 batteries, you can just add more later down the road. So that's the beauty of our product is it's expandable later down the road. You can actually come back 2-3 years later and add additional capacity to the system. So let's do an example. I'm going to get ready to pull up the first poll question. So everybody wake up, make sure you're paying attention here. Let's say a customer's utility bill shows 20 kilowatt hours of consumption per day on average, and they've got a maximum peak power demand of 7 kilowatts. They really don't have a ton of long outages, so they really only want 1 day of autonomy, and they're going to go with 90% depth of discharge, like I said. So at 90% DOD, you can take the 3.8 kilowatt hours or 3,800 watt hours and multiply by 0.9, and you get 3,420 watt hours per battery. So how many batteries do they need? I'm going to pull up the poll question here. All right, so go ahead and let me know how many batteries you think they need to meet those needs. Make sure to consider not only the kilowatt hour consumption, but also the peak demand. So can that number of 5 batteries also support the peak demand? Give you guys probably about a minute here. And again, if you joined us late, make sure to answer these poll questions for your chance to win a shirt and a hat. All right, another 10 seconds or so. Get your answers in. All right, so most people said 6 batteries are needed. Let's see. I also got 6 batteries. Now, does that meet the peak demand though? If we multiply 6 times the 1.9 kilowatts that each battery can discharge, that's well over 7 kilowatts. So yes, that does meet the peak demand. And for example, we could just use an access unit for that with a SolarArc 12K. The 12K can easily meet that 7 kilowatt peak demand, and 6 batteries would work great in our access unit as well. So let's move on to one more example for whole home backup. So let's say 2 years later, that same customer, they now use 30 kilowatt hours a day and have a 9 kilowatt peak power demand. And they've decided that when they have a power outage, their whole neighborhood comes over and they have a big slumber party and whatever. They want 2 days of autonomy now. So the total energy consumption is going to be 60 kilowatt hours since they need 2 days of autonomy. How many batteries are they going to need? And again, they're at 90% DOD. So I'm going to open this poll. Let me know how many Phi batteries they need. Gonna go with another 45 seconds. All right, almost everybody has answered. 10 more seconds. Alrighty, looks like most people said 16 batteries. Actually got 18. So if you divide the 60,000 watt hours by 3,420 watt hours, I get 17 and a half batteries. Gonna need to round that up to 18 batteries total. And 18 batteries can easily meet this 9 kilowatt peak power demand. Not a problem. It's only about half a kilowatt per battery. So what I would do here is if they already have the Solar Access with 6 batteries, I'll go ahead and add a 12 battery Boss cabinet. It's Boss 12. So that's a great, easy, and beautiful way to put these batteries in a customer's home or even outside. So now let's move on to critical loads. When you're sizing storage for critical loads, know that you can just take whatever loads you want from the main panel and move them over to the critical loads panel. Now, most times, however, this type of system is going to be sized so that the PV or generator or hopefully renewables can actually recharge the system daily. Because these are truly critical loads in many cases. We're talking maybe medical devices, maybe just keeping the fridge running. Therefore, since it's sized to recharge daily from renewables, you often are not going to need a smart panel here. You can size first, you're going to size based off of kilowatt hour consumption and instantaneous demand. Now, for these, since your utility bill isn't going to show you which appliance used what amount of energy, you're going to need to do a load calculation. So we're going to do a load calculation a little later when we get to off-grid, and you can repeat that same thing for this example if you'd like. Usually, since it's sized to recharge daily, though, you're really only going to need 1 day of autonomy. And for a daily cycled system like this, you're going to often size for 80% depth of discharge. That's going to give you the longest lifespan of the batteries. So if you've done your load calcs and they revealed an 8.5 kilowatt hour a day consumption with only a 5 kilowatt peak from critical loads, then again, your PV system is sized to recharge daily and you're going with 80% DOD. Tell me, how many batteries do you need? I'm going to open the poll here in just a second. Awesome. Are we going with 3 or 5 batteries? Let me know. I got a question about who the smart load panel vendor is. NAC is one option and Lumen is another. Those are just two that I know of that work well. I'm sure there's many out there, but we've definitely collaborated with Lumen and NAC and can confirm that they're good options. I've got another question. Should it be 18 each? So for the previous example, the customer started with 6 and then added on 12 later down the road to make 18 total. And 18 total gave him that 2 days of autonomy. So no, he didn't need 18 for each day, just 18 total. Alrighty, got almost all the responses in, so just another 10 seconds here, and then I'm going to close this poll. All right, so most people said 3, and I got the same. I got 3 batteries. So when we look at, the capacity of 3 batteries, that's definitely going to be able to exceed that 8.5 kilowatt hour a day consumption. How about the critical loads? Now, if we multiply 3 times 1.9, we get 5.7 kilowatts DC. That's definitely going to be able to meet the peak power demand there. But one point is to be sure that if your batteries are only sized to provide 5.7 kilowatts, make sure that you're not choosing an inverter that can then go ahead and provide 8 kilowatts, for example. That's a great way to leave your customer room to expand their loads down the road and destroy their battery bank. So I think a lot of people, when they're getting started off in offering storage in addition to PV, they don't even realize that batteries actually have a rate that they can discharge at. So that's not really something that a lot of first-time installers consider before installing the system. They just think about the overall capacity. So don't make that mistake. For an example of what the critical loads would look like, I made a quick diagram here. Let's say that your customer already has an existing AC coupled PV system that lands on a critical loads panel, but maybe the loads panel doesn't have any loads on it currently. So you're just going to take those loads from the main panel, move them over to the critical loads panel, and throw an access unit in between the two panels as kind of a buffer between the loads and the grid. So hopefully that's pretty simple. A lot of times your AC coupled systems are outside. All the equipment is already outdoors. So it's easier to just throw in the NEMA 3R rated cabinet instead of, putting in indoor equipment, but you can do it either way. For a DC coupled example, maybe you're installing a brand new system and your customer wants a critical loads panel to stay on all the time. I think this is a great way to do it. You can really scale these systems up. So I wanted to give you an example of a large system here. 12 batteries in each cabinet, 2 cabinets combined on a midnight combiner. That makes 24 batteries. And let's say that your Solarc, again, is going to be your buffer between the main and critical loads panel. So and also I use the Tigos in this example, of course. So don't forget that transmitter. Had a couple people call me that they forgot their transmitter, and I held them up a couple days. So that was a bummer. As far as sizing for a really more, a newer application, something that's coming up as utilities are charging different rates at different times, is peak demand charge avoidance and time of use arbitrage, sizing for those. So peak demand is really when your utility company is going to put in a charge, maybe a flat fee or maybe a per kilowatt fee when you reach, when you pull above a certain amount of power to your loads. So if, for example, your utility company says, hey, we're putting in a 10 kilowatt limit, anything over that, and you get charged a peak demand fee, then you're going to make sure that your battery system can power anything above 10 kilowatts. In most cases, you're really going to need a DC coupled system to make sure this happens properly, because with a DC coupled system, you can have a self-consumption feature, right? You can have that feature and have control over where your power is going, instead of an AC coupled system where, the grid and the solar system are kind of just one. They're kind of combined together. So this is a function of the inverter. It's not a function of the batteries. The batteries are definitely capable of this, but not all inverters are capable. So make sure your inverter has this feature. You're going to want to consider, what is that threshold that the peak demand charge kicks in at? How much power are you consuming beyond that? So maybe your peak demand charge kicks in at 10 kilowatts, but your max peak usage is 14. So you'd need that 4 kilowatt void filled by batteries. You're also going to want to factor in, how long you need that load powered for. Is it just a couple minutes, or is it several hours each day? Really, you should be able to get this data on how much power you're using and when from your utility company, but it's not going to appear in such fine resolution on your utility bill. You're going to have to request the, kind of 15-minute data chart from them. They should be, obligated to provide it to you. So just get your installer to request that info from them. So for example, let's say a utility company is going to charge you 1.5 times for any power usage over 50 kilowatts, but you've got a demand of 75 kilowatts maximum. So in this case, you need a battery bank that's capable of discharging at least 25 kilowatts, and that's going to be able to, shave that load for you. Take that 75 kilowatt load on the utility and shrink it down to 50. So then here's where it's going to come into play how long you need that load powered for. If you just need it for a couple minutes, you can take advantage of that maximum surge discharge of 10 minutes of our Phi battery. That's actually over 4 kilowatts per battery. So if you just needed a 10-minute surge, you could divide 25 kilowatts by 4 kilowatts. I get 7 batteries. If you needed a longer surge, so maybe an hour or an hour and a half, then you're going to divide by that 1.9 kilowatt continuous discharge rate. 25 over 1.9, I get 14 batteries. So that has a big impact on the size of your system. As far as time of use, these rates are becoming a lot more common. Utility companies are basically requiring everyone to adopt these over time, especially solar and storage customers. So TOU is when there's a specific rate for a specific hour of the day. So if you're buying power from the utility between midnight and 6 a.m., maybe it's really cheap because everybody's asleep. But then during, the hours of 4 to 9 p.m., when everybody's home from work and there's a big demand, they hike up the rates because they're using a dispatchable power source instead of a base load. It's more expensive for them to operate, and a lot of times it's less eco-friendly too. So In these cases, you really want to mitigate your demand during the 4 to 9 hour. You actually would hopefully want to sell power back to the utility during that time. If you bought power at a cheap time and sold it back at an expensive time, you could build up a credit on your utility bill to then use later down the road if your solar production wasn't as good in the winter, for example. However, you can't quite use this to just make a lot of cash. Really, at the end of the year, if you have leftover credits, their value goes way, way down for cash value. So just note that this is really helping you to deplete your utility bill. It's not going to help you get rich. So what you're going to want to do is find out, of course, when the time frame is. You're probably going to need a DC coupled system here again because you need control over where your power is going and coming from. Again, with an AC coupled system, it's harder to do, but you could maybe use grid use timers. It really wouldn't allow you to sell power during that time, though, because the grid would be disconnected. So you should be doing load calculations here based on the energy consumption and peak power demand. Or you can get the help of your utility company and just request that 15-minute data. So for example, if you're charged double from 4 to 9 p.m., and you're using an average of 6 kilowatt hours during this time, then your battery bank should be at least 6 kilowatt hours in size. Simple as that. Make sure that your battery bank can meet your peak demand during that time as well. So for this example, you could use two Phi 3.8s to meet that 6 kWh need. That's only going to provide you with a 3.8 kilowatt continuous power discharge. So make sure that that is enough for you as well. Sweet. So let's move on to my favorite, which is off-grid. If you're living off-grid, you're really most commonly going to be using a DC coupled system. So usually there's no need for a critical loads panel. There is no grid connection for the inverter to buffer between the critical and main loads panel. There's no need for that because there's no grid connection. Even if you have a generator, this is still really not an issue. You're really not going to need a separate panel. Your sizing is going to be based on a detailed load calculation. So obviously you cannot get data from a utility on a house that doesn't exist and that they're not connected to. So you're going to need to calculate this by hand. And I definitely would recommend sizing for 80% depth of discharge because you're going to be using these batteries daily and you want them to last as long as you can. So for example, this is very similar to our previous example for critical loads. However, there's just no grid connection. There's just loads here. So you can scale these systems infinitely again with the Phi batteries. This is just one example here. As far as your load calculation, this is just an example of what mine often looks like. So I line up the appliances that the customer needs to power, the power draw of each appliance, and then I ask them, how many hours do you run this each day? I start with their base loads, such as things that are running all the time or things that have a constant, a similar load each day. Like lighting, you're going to leave that on for about 5 hours a day. The load is not going to change a whole lot. The Wi-Fi router, for example, that's running constantly. It's not going to turn off, so 24 hours a day, every day. So you multiply the power draw by the running hours, and you get the energy demand in kilowatt hours. When you're moving on to their variable loads, these are things that they can control a little bit more. They can lessen when they need to. So, for example, they're not going to be running AC in the winter when there's no sun power. In this example, I actually used their water heater and dryer. I just imagine those were going to be run on propane. Those are some big loads, and a lot of times, customers want to add those later down the road. Luckily, our batteries can be expanded on later. But Note that if you're going to add, hot water in your washing machine, you're going to be using an electric dryer or an electric water heater. Those are going to be some big loads that have a massive impact on the size of your battery system that you need. So make sure you don't forget those. Check with your customer first. Once you've totaled the power draw and energy demand, then you can, I would say, add about 10% in general to the kilowatt hour energy demand to account for losses in the system. So I'm talking about losses through the inverter, losses through the battery bank. Luckily with ours, it's really only about 1 to 2% round trip, and losses through the wires as well. So that's where I get that round number of 10%. You can actually go through in more detail and calculate that if you want for your system, but I find that number works just fine 99% of the time. As far as adding that, you just are going to multiply your energy demand by 1.1. Your days of autonomy is 1, so you just need an 18 kilowatt hour battery bank. Again, this is a scenario where the PV or hydro, wind, whatever, that's going to be sized to recharge the system daily. If you're living off grid, you're not going to be, waiting to go 3 days without a grid connection. You're always without a grid connection, so you kind of have to size for 1 day of autonomy. So if we've got this example here, we've got 18 kilowatt hour demand and almost 9 kilowatt peak. How many batteries am I going to need? I'm going to open a poll for you guys. This is the second to last poll, so get your answers in here. Another note here, make sure you're rounding up. So if you're at a decimal number and not a whole number, then you're going to need to round up instead of down. Okay, about 30 more seconds here. All right, looks like that's everybody, pretty much everybody. So I'm going to end this poll. Awesome. Most people got 6. I got 6 as well. That is the correct answer. So I got 5.92 batteries, and I rounded up to 6 batteries that are needed for this system. Again, the beauty of the Phi batteries are that you can really add more later down the road. The SimpliPhi as well. These are a 3.8 kilowatt hour building block so that you can really make a custom size system for each customer instead of adding, a giant 10 kilowatt building block, 14 kilowatt building block to each system that just is maybe way oversized for your customer. So again, it's a lightweight battery. It's about 80 pounds, and that's going to allow one person to carry it in and out of a job site, easily install a giant bank on their own, and a C/2 charge rate. So the C/2 charge rate is really helpful, for example, for off-gridders. If you've got a giant generator that you don't want to leave just trickle charging a battery, you can cram a big amount of current into that battery in just 2 hours, fully charge it. Or let's say you've got a large PV array that's shaded for most of the day and you want to maximize those 2 hours where you get full sun, no problem. Even I see a lot of off-gridders with multiple charging sources. So they've jerry-rigged up a wind turbine or even a hydro wheel. I've seen a lot of crazy hydro setups that are just super cool. This is an advantage of the Phi batteries, is that they can work with multiple charging sources that might reach C/2. It allows you to charge very quickly, but know that often in a residential scenario, you're not going to be seeing a C/2 discharge unless you're doing that, peak demand charge avoidance. Most residential systems are going to be discharging at a much slower rate, more like C/5 or even C/10. It's really the charging where that C/2 rate comes in handy the most. So let's talk about replacing an existing battery system. If you've got lithium batteries, probably the first thing that's going to come to mind is their communications. So is your battery communicating with its inverter currently, and is our battery going to do the same? Or if no communications are needed, just making sure that that equipment has customized set points that you can enter in exact values for. You might want to compare the spec sheets as well, but they're going to be within the ballpark range of each other. Whereas with lead acid batteries, the depth of discharge, efficiency, and charge rate are just nowhere near. I mean, we're talking lead acid batteries are used at 20 to 50% depth of discharge. Our lithium iron phosphate batteries are used at 80 to 100 percent depth of discharge. So really, you're going to have a lot smaller battery bank that's capable of providing a whole lot more energy and power. Same goes for efficiency. Lead acids are not all that efficient, especially at high discharge rates. And our batteries are 98% efficient round trip. Another big thing you want to look at before replacing your lead acids is the equipment compatible with our batteries? So is your charge controller or inverter able to hit the correct charge settings or low battery cutout that is required for our batteries? For example, that's going to be 48 volt low battery cutout. For charge settings, I'm not going to go into detail right now, but we have a ton of guides on our website, and just email me and I'd be happy to help you. As far as sizing, you're going to match or exceed the usable kilowatt hour capacity. So you're not sizing based off of the total capacity. You're going to only think about what's the depth of discharge that customer is using. Are they using 30% of their lead acid battery bank? Okay, I'm going to multiply the total capacity by that 30%. We do have an awesome calculator. Unfortunately, not going to open this right now because I know it's not going to work the way I have my screen sharing set up. But if you have a lead acid bank, you need a little help calculating how to replace it, check out that calculator or email us. We'd be happy to help you. Alrighty, time for the last poll question. Tell me how many batteries are needed in this case. So we've got 8 batteries per string. We've got 2 strings for a total of 16 batteries that are each 6 volt, 300 amp hour flooded lead acid batteries. Customers currently using only 30% depth of discharge. So tell me, first off, how many kilowatt hours total? How many kilowatt hours usable? And then how many Phi batteries are needed to match if we're using 80% depth of discharge? I'm going to go ahead and launch that poll. And to convert kilowatt hours to watt hours, you just multiply by 1,000. Remember, we're not sizing based off of amp hours here. Lead acid batteries have a lower, nominal voltage. So if you were to just use amp hours, you would miss that voltage advantage of the higher nominal voltage of lithium batteries. All right, I see not many people are answering yet. I'm going to try to give you guys some hints here. The number of watt hours in one of these lead acid batteries, I multiply volts times amp hours and get watt hours. So 6 volts times 300 amp hours gives me the number of watt hours in one lead acid battery, because a volt times an amp is a watt. So remember, for usable watt hours, you're going to take the total number of watt hours and multiply by that 30%. I want to give you guys some more time on this question. I'm going to jump through a couple of the questions that came through. So somebody asked how I sized the refrigerator load in my load analysis. So what I did was, you can look at the yellow tag that comes with your fridge. It tells you how many kilowatt hours your fridge is going to use per year. Divide that by 365, for example. My fridge uses about 2 kilowatt hours a day. All right, looks like we're getting close to everybody answering this one. If you haven't submitted an answer, just go ahead and toss one in now. I'm going to give you 10 more seconds. 5, 4, 3, 2, 1. All right, so most people are saying that there's 28,800 watt hours. That's correct. Now, let's go through the math, though, before we jump onto the rest of the answers. So we've got 28,800 watt hours. We multiply that by 0.3 for 30%, and we get the usable amount of watt hours as 8,650. That's 8.65 kilowatt hours. We divide by the amount of energy in one battery at 80% depth to discharge, and we get 2.8 batteries needed, so we round up to 3 batteries. So note that you're replacing this giant bank of 16 lead-acid batteries with just 3 5 batteries, and you're actually ending up with more capacity than you need. One note, of course, though, about the installation when you're replacing lead-acid batteries. Lead-acid batteries are often wired in a daisy-chained method. So we don't do this with our batteries. It's going to create imbalancing and improper sharing of current. It's going to wear some batteries down faster than others. And generally, the batteries won't be balanced as well during charging either. So don't daisy chain or wire terminal to terminal. Instead, make sure you're wiring all of your Phi batteries to common bus points. So all your leads are going to be the same length, same size cable. So for example, maybe you've got 8 2 gauge 4 foot long cables here, one positive and one negative for each battery, all go into a combiner. That combiner, your charge controller and inverter can land on that same combiner. For example, in our access units, they come with a terminal block, 5-point terminal block. Same with our boss cabinets. Lastly, I want to touch on our IQ program before jumping into the Q&A. Our IQ program is able to highlight installers and really show your location on the map to customers. So it also allows us to really highlight you as an installer in our own marketing and our newsletters. But know that the where to buy map is where our sales team is going to show customers who are looking for an installer. They're going to point them towards this map and tell them to find one near them. If you're a distributor, I would highly encourage you to get your installers involved in this program. It's going to keep a steady flow of SimpliPhi sales coming your way. It's going to make for less technical support on your end and our end because your installers are going to be more knowledgeable after installing the same product over and over again and knowing how to modify it to meet the needs of each system like we did today. Again, it's going to allow you to use our logo and show your distinction over other brands. You can apply here today in just a couple of minutes. If you have any trouble with that, I'm putting my email at the end of the screen. You can email me as well, and we can go through it that way. All right, so for the Expo Hall passes, if you're an installer, please submit your photos to training@simpliphipower.com. That way I can get you not only IQ certified, but I can get you a free Expo Hall pass for SPI in New Orleans this year. I've got 3 passes to give away. So send in your photos, first come, first serve. I want to get you guys IQ certified and I want to get you free passes. All right, now I'm going to go ahead and open the question and answer bar that you guys sent in a bunch of great questions. What does the installation and integration of a smart load panel look like? Wow, that is a long answer that I could give you. Instead, I'm just going to say, why don't you go check out one of Lumen's videos? They definitely have several videos on the installation of this. They really use only certified installers. Only 1 day of autonomy for off-grid? What about really cloudy days? Suppose a PV system only. I'd say many off-gridders have a generator. Many off-gridders are sizing their PV system such that even on the worst cloudy days, it's still able to recharge their system. You really got to know your area and know PV sizing and shading and angles and all of that jazz to be able to do this correctly. Off-grid sizing is much harder than grid tied because you don't have that extra help of the grid to rely on. So sure, other people do it other ways. I use 1 day of autonomy and it works well for me. Is that realistic? It's realistic. Again, there's a lot of factors there. You don't have to use 1 day of autonomy if you want to be more cautious for your customer. I would instead increase the size of the PV array, but you could definitely just increase the size of the storage or add a generator as well. What impact does an old battery bank have on new batteries when you scale up? So that's a good question. If your batteries, your lithium batteries are, let's say you've bought your 5 batteries in 2020 and you want to add more in 2021, so just 1 year difference, it's going to be really no problem. Know that the warranty reverts back to the length of the warranty of the oldest battery in the system. So if you installed brand new batteries in 2021, they would have a 9 year warranty essentially at that point, instead of the 10 years that they would have if you installed them on a brand new system. So I think that can kind of speak to what happens to the batteries when you scale up. But this is really not even an option that you have with lead acid batteries. If you were to add lead acid batteries to an old lead acid system, they would most likely destroy each other very quickly. What charging amps are needed to achieve C over 2? For our Phi 3.8 kilowatt hour 48 volt battery, it's a 75 amp hour battery, so half of that would be 37 and a half amps. That is our maximum continuous charge rate. What is the cutoff period? Technically, there is no cutoff period to adding new batteries to an old bank. However, because the warranty reverts back to the length of the warranty of the oldest battery in the system, I would suggest keeping that to 2 or 3 years if you can. But even so, later down the road, if your customer just needs one more battery, it's often more cost effective to just add that one battery than replacing the whole bank. Can we get a copy of the slides? Absolutely. Everybody who attended or even registered is going to get a copy of the recording. I'm not going to talk about supply chain issues, but you're welcome to call our sales team because they have all the info on availability of our products as well as lead times, what's in stock at different distributors. We've got plenty of stock and plenty of availability right now on all of our products. So, if you need something, don't hesitate to reach out to them. My email is training@simplifypower.com, but the sales team is just sales@simplifypower.com. Very few customers still have their yellow fridge usage tag. How would you calculate it without that? Great question. So you could use what I call, well, not what I call it. It's called a kill a watt meter. If you search kill-a-watt on Amazon, you will find a small little meter that plugs into your wall, and then you'd plug the fridge into that. That's going to keep a record of how much power your fridge used, how much energy it used, over whatever period you leave it plugged in for, and then you could divide by the number of days and get the average power usage per day. That is how I would do it if I did not have the fridge tag. Thanks, Josh, for coming. Thanks for the great comments. Good to see you. When we are calculating loads in the house, the load is based on AC power, while the batteries are calculated based on DC power. Can we consider AC load to equal DC load? So make sure you're accounting for the efficiency loss through the inverter. I find that often it's between 5 and 8%. That's a great question, Rabbi. Good question from Gary. Does the battery monitor internal temperature to prevent charging at or below freezing temperature? That is, if you're in need of preventing charging below freezing, make sure you check out the SimpliPhi battery. The SimpliPhi battery is going to speak to the solar and tell it to stop charging and even slow the charge rate as necessary as it gets very close to freezing. Karen Houston, thanks for coming. It looks like Karen does 2 to 3 days of autonomy for her off-grid customers. That is awesome. So make sure you check out Karen Houston if you are looking for an off-grid installation. I've spoken to her several times and I know she does great work and she can install our batteries as well. We receive batteries without any kind of communication ports. Will these work with Schneider equipment? Yes, so our Phi batteries do not have communication. Those are compatible with Schneider. You're going to want to make sure, though, that you check out our integration guide for the correct settings. Since if you do not have communication, you're not going to want to go on the state of charge triggers. You're just going to go on voltage triggers. Thanks for the kind words, Andrew. Lead time for delivery, that's going to vary based on where you are, what distributor you're ordering from, and what product you're ordering. However, know that we have stock at distribution centers, so it's shipping out very quickly. And if you have a question and you want a specific answer on a specific product, just email me or our sales team and we'll get back to you. Vicente, thank you for joining. Email me and we'll get you through our IQ program. Can you recommend a solar power meter for off-grid? Not sure what you mean specifically, but one meter you can use for state of charge monitoring, for example, to see how much juice is left in the bank of your batteries. The Victron BMV 700 or 712, those are great options. They do a pretty accurate job of calculating state of charge. Got a question about temperature from Fernando. Let's see. Maximum temperature charging. You do not want to charge your batteries above 120 Fahrenheit or below 32 degrees Fahrenheit. So that's freezing to 120 Fahrenheit. However, you can discharge them all the way from -4 degrees Fahrenheit all the way up to 140 Fahrenheit. So it's a really wide temperature range, especially for discharging or just resting. Is it okay to be installed in sunlight for the next 10 years? I mean, if you're using an access cabinet and putting it outside, that's absolutely not a problem. But the batteries should not be installed outdoors. They're not outdoor rated on their own unless they're, inside the cabinet is when they're outdoor rated. Please, can we use a normal charger for lead acid battery to charge lithium battery? Yeah, I wouldn't do that if you want it to last very long. We have plenty of chargers we can recommend for you, but if you're going to use a cheap old charger, it's probably going to, not work as well as a nice new lithium charger. Awesome. That is all the questions that I see here. Thanks everybody for joining and for the great questions. Got a ton of questions today, ton of poll answers. I will be soon contacting the winner of the hat and shirt as well as the passes for SPI. Make sure to submit your photos to my email and I'll send out those passes to you guys. First come, first serve. Alrighty, everybody. Have a great day. Thanks for coming.